Okay, guys, this is take two on 15 through 17 because whatever I did in iMovie wouldn't open by many of you. I'm hoping that this one opens. So this is a backtrack. I'll put it back up there after I'm done. Okay, so pages 15 and 17 just want to know the difference between rational versus irrational. So the things you want to know about rational, in case you didn't write them down, is rationals are ones that can be written as fractions, A over B form, terminating decimals, meaning they end like 2.5 stops, ends, or repeating decimals like 0.3 with the bar or 0.45 with the bar, goes on and on and on in a pattern, okay? So when you go through this, and don't forget the chart over here, real numbers, rational, irrational, integer, whole number, natural number. So if you're a whole number, you're also an integer, a rational, and a real. So, but basically today they're asking us the difference between these two. So what it says over here, if it's integers are rational, yeah, because integers are below and going up one makes them rational, so that's true, okay? And integers you can all write as fractions. Zero is irrational, yeah, because zero stops. It's a number we can write as a fraction, zero over anything. Rationals are integers. That's false because not all rationals are integers. Like think about 1/2. That's a rational, but it's not an integer. Okay. Decimals are rational. Again, not all, only the repeating decimals and the terminating decimals. So that's why I circled false there. Pi is definitely irrational because we all know 3.14159 dot, 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 dot goes on forever, doesn't have a pattern, so that would be irrational. So that's why I circled false. And all fractions are rational. Yes. Okay, if you can write it as a fraction, it's rational. So down here, where you're looking at these problems, examples, they're saying which choice is rational. I basically plugged them all into my calculator, and this is the only one that came out as a nice number. The rest of them were non-repeating, non-terminating. They were long, and they didn't have a pattern. So that's why that's the answer. Over here, what's not rational basically means what's irrational, and if I repeating we said was okay, so it's not that choice. Terminating would be all right, is rational, so it's not that choice. When I do the square root of 5 in my calculator, it comes out to a long number that doesn't have a pattern and doesn't end, so that's irrational. And if you add 2 to it, it's still irrational. And on the last one, it turns out to be 3. So that's why I circled that one. We skipped number 3. Number 4, same idea. Which one is a real, an integer, or a real, rational, and an integer? Well, you can eliminate 2 and 4 right off the bat because they're not integers. Fractions can't be integers. So then I just had to check the other ones. When I did this, this would be really like saying 7 minus 6 is 1. And this one is, square root of 15 is definitely irrational if you plug it into your calculator. And if you add 8, it's still, so the one that's an integer is 1. And down at the bottom, a rational number represented as a decimal or a terminating or repeating decimal. True, that's the definition. Terminating or repeating is rational. And then we skip under that. Okay, now on the other page, what you want to see is irrational. So what you might want to add to your paper, if I didn't write this on there already in your notes, I can't remember honestly. Irrational is non-repeating, no pattern, that means, and non-terminating, which means no end. So it just takes up all the space it can on your calculator. It has no pattern, doesn't end. Even though your calculator makes it look like it end, it really doesn't. So if I typed in the square root of 2, I'd get 1.41 something, something, something going on forever without a pattern. So yes, that's irrational. That's why that's true. This one is a repeating decimal, so that's not irrational. That's okay. That's rational, so I circled false. Pi, always irrational. 3.14159 keeps going on forever. That's true. 144, though, the square root is 12. So that's a nice number, so that wouldn't be considered irrational, so that's why that's false. If you actually figure this out, either put it in your calculator or it means the square root of 3 times the square root of 3 would actually turn out to be 3. So that 3 is not irrational. 3 is rational, so that's why I circled false. And again, when pi shows up, it's got to be irrational, so that's why I said that's true. Down here, which one is not rational or irrational, which means rational. So I had to like plug them in my calculator and realize that that's the only one that came out to a nice answer. So that's rational. That's 2. And non-repeating. The rest were non-repeating, non-terminating. Over here, for which is irrational, pi wins every time. Okay, plus these are terminating. That's a fraction. That's terminating. They can't be irrational. Skip number 9, go to number 10. Irrational numbers have exact locations. Well, no, they can't because they go on forever and they don't have a pattern, so you can't really say exactly where they are. We have to estimate them on a number line. Number 11 is true. when working with a circle, you're going to have answers that be irrational because the formulas you remember from last year have pi in it, and since pi is irrational, your answers are irrational. You always have to round them. And which best describes the number 3.14. Now don't get confused because it's not really pi because it doesn't go on forever. And so this is a terminating decimal, which makes it rational and real. I'm trying to trick you on that one. Okay, that's it for that page. One more page, 17. I'm going to couple things. I know you have this all in your green packet of notes anyway, but just to show you how I did a couple of them, let you know. Basically, use your calculator to help. Square root of 25 is 5. So I go and I put a dot right on 20. On 5, but I label it with the original, so you notice I labeled it square root of 25. Negative 2/3 is a little more than halfway to 2, so I just put a dot there, labeled it negative 2/3. Again, use my calculator for the square root of 50, got 7.07, that rounds about 7.1, so I put a dot right there and put the square root of 50 over the top. And then 6 1/4, I could tell where that was, a little more halfway, a little less, put a dot, and then go there. All right, and I did the same thing on the next one. And again, I used my calculator when I didn't know what it was. And I put the original answers where they were. And you can check your notes for the last two. So I'm going to stop there. Hopefully this video uploads. All right, hang in there. Stay tuned.